video, we're going to be talking about osmosis. Now, before we move on to osmosis, we first must understand diffusion. If you didn't know, osmosis and diffusion are pretty much like the same thing. So basically, in a summary of diffusion, the high concentration molecules are moving to a low concentration molecules so that they can equalize and have an equal amount of concentration molecules on each side. Now, diffusion can happen with solid, liquid, and gas. So an example would be like incense sticks or perfume. Here I have incense sticks, so we'll just like light up the incense sticks. We'll diffuse the gas so that it can go into our air. Alright, you can see the gas that's coming out. And you see perfumed gas that's being diffused into the air. This is an example of diffusion. If you were to also breathe it, you would get the smell too because it's perfume. Alright, we'll move this incense sticks to the side. I'll move on to our next example. So for this example, you're going to want to use hot water. Why are we using hot water? When comparing to cold water, hot water molecules move much more faster than cold water molecules. Because of that, this increases the diffusion, and we don't want to wait a while to be able to see the diffusion. So we have hot water. You can see on this candy that it's filled with sugar. Sugar is high concentration. But if we were to go into the middle has nothing. This is low concentration. If I were to pour water, all of the color and sugar would move to the middle. So we pour it into the middle. I'm just gonna leave it there. Now because it's hot water, it's gonna increase the speed. We can see that now the color is starting to separate. Over here, you can see the orange, the brown, yellow, you can see that. And you can see these dividing, you see? They're slowly starting to create a pattern. Now, of course, they start at the side because there's sugar and color, which makes high concentration, but they move down to the middle, which is low concentration. So it's equalizing, and this is another good example of diffusion. Unlike osmosis, there aren't any barriers. They can move wherever they want, pretty much. Like you can see this one spreading to this one over there, spreading over there. See, there's no barriers. And this is how diffusion works. It just moves from high concentration to low concentration. Alright, now we're going to move to our osmosis. Osmosis is basically the movement of high concentration going to low concentration or equilibrium happening through a semi-permeable membrane. This semi-permeable membrane is also known in simple terms as a barrier. Now, osmosis can only happen in liquid state. It cannot happen in gas or solid state. An example of osmosis would be like, let's take a plant, okay? If we look at the plant's roots, how is the water supposed to be distributed to all of the cells? Well, basically, osmosis, or the movement of high concentration to low concentration from a semi-permeable membrane, what happens is the water will be low concentration. It'll go inside of the cell, and then that will equalize everything. Because of that, osmosis works in living organisms. Now, osmosis is very important in many ways. So if you were to look at their significance, things like waste disposal or the allowance or nutrients can easily go in and out of a cell easily through the process of osmosis. Okay, how come some plants need fresh water to survive, but other plants need salt water to survive? Let's see why by using this simple experiment. So we're going to be using potatoes over here, and we're going to have water filled in each of these cups. Then with the one that's labeled with sugar, salt, and tap. For tap water, we're just going to put water. For sugar, we're going to put sugar. And for salt, we're just going to put salt. So we're first going to do that, then I'll explain the next steps. Now that we added the water, we're going to leave this alone, and we're going to fill this with sugar, this one with salt. Alright, while we're letting this dissolve, we're going to add all the sugar. Alright, after some diffusion, we've come back. So let's talk about what happens when you put the potato in salt, sugar, and tap water. So let's first make a hypothesis about the tap water. In my hypothesis, I would just say that it would pretty much be the same, because I'm pretty sure if I put water in any substance, nothing would happen to it except for getting wet. So I'm pretty sure nothing would happen for potato, but if it were to be sugar, well, I think this would thicken a bit more because it is sugar. Also, don't plants have glucose? The glucose, which is pretty much used as a plant's food. So I'm pretty sure this will like thicken up a bit. And glucose is nothing but the plant's food, if you didn't know, which is nothing but sugar, by the way. I think this will thicken up, and I think it'll get a bit flexible. This one for salt. Now here's the thing. I think it'll thin out because all the water is going to be drained. I think it'll be a bit more flexible without the water holding the whole structure. So let's see. Okay, we're gonna put 2 in each because we have 6 in total. So water. Now we'll put sugar. Next we'll put salt. And we'll wait for about 30 minutes. So it's been more than 30 minutes, and we're gonna go and see how our potatoes came to look. Let's first start with tap water. Okay, so this is the potato. It's still hard and rigid, like not flexible. It's still the same as it was before. Let me try. Next, we're gonna move on to sugar. Okay, so the sugar, let's see it. Okay, this is definitely more flexible, just a little bit more flexible, not as much, but it's much more flexible than the water one.
Yeah, he's right.
Now let's move on to the salt. Oh, this feels already very smooth. Oh, this is very flexible. See that?
It's so flexible.
I guess my hypothesis was a bit correct. So the scientific evaluation is that the potato already has water, but if you fill the water with just if you have regular water, it'll stay the same. Sugar water will be a bit flexible and thick, but with the salt, it would be very thinny and skin. So let's say we put a lot of salt water near the plant's roots. The plant's roots will pick that salt water up, but because it's salt water, what happens is that through osmosis, what happens is the salt, and because salt is very high concentration, the salt will try to equalize it so that it will go inside the cell membrane. When salt is near water, what happens is that the water drains out, leaving the cells and the plant to be dehydrated, shriveling up, and if you have too much salt, it'll die.